So in this class, we'll do this numerical test portion, 8D, okay? These questions on your textbook. So let us start with question number 1, which we'll find on textbook page 116, okay? Open your textbook to page 116. I will read the question for us, okay? A bus starting from rest moves with uniform acceleration of 0.1 meter per second square for 2 minutes. So let us write that down. Since the bus starting from rest so this is going to be a keyword here in this question, moves, okay, moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. So right here, for 2 minutes. So from this statement of question, we can here derive these values here from rest means this question is suggesting that the bus was stationary in the beginning. Rest means stationary, so that means the initial velocity was 0 meter per second. Here meter per second, the SI unit of velocity is the initial velocity of the bus. Then with a uniform acceleration, so that is usually denoted by A, 0.1 meter per second square. The unit for acceleration is this meter per second square. 2 minutes means we know that is time, so T is equal to 2 minutes. But we know we are following the SI system, and the SI system follows the, as we have discussed in our previous class, the MKS system, which means for distance we follow meter, for mass we follow kg, and for time we follow seconds. So we need to change this minute to the SI unit of time, second. So for that, we have this conversion factor, which are quite easy. 1 hour, 60 minutes, and 1 minute, 60 seconds. So the conversion factor here is 60. So if you're changing minute to second, you're shifting one place to the right. It's changing a bigger to a smaller unit. So we need to multiply this 2 to 60. Then this minute will be replaced by second. So that is 120 seconds. Okay. UAT is there. Now, what is the question asking? Find A, the speed acquired. So A is nothing but final velocity, okay, which is mentioned in your question as speed acquired. Okay, in the textbook questions, speed acquired is interchangeably used with velocity, okay, even though in the strictest sense, velocity and speed are slightly different, and this is accepted, okay. Then B is here, the distance traveled, right? So distance traveled here we're denoting by our S, which is S question mark, the distance traveled. So now UAT is there. To find A, we can simply use this equation. U, A, and T are given in the question, as you can see here. So we can directly find out by using the first famous equation of motion, V is equal to U plus AT. So U is here, nothing but U is, as you can see here, 0. So we write there 0 meter per second plus here A. So we can see here 0.1 meter per second square. If you brought this second to the power minus 2 down, then it becomes plus, right? Into T, so A into T, and time is 120 seconds, as you can see here. Time 120 seconds. Fine. So this second to the power 1 and 2 minus 1 cancelled, and this 0 to multiplied means everything will disappear. And now let us use this 0 here. Single 0 here means it is 10. So when you multiply decimal to 0, it moves right. So it will go to the right side of 1, become 1. So we can just neglect this part, right? And so we have only 12 left, right? So 12, and then here meter, and this second one more is left here that you bring to numerator, then second to the power plus 1 is there, right? So that will become minus 1. So therefore the speed acquired by this bus is 12 meter per second, the first answer. Okay, this one. Okay, next B, we have to find S. So for that, maybe we can just write here B. Directly we can use formula number 2, I think, because you see here UT80 is there, UT80. So we can just use that, since we know that S is equal to UT plus half AT square, using this famous equation for motion, right? The second one. So let me just bring the equal here because we need space on the right side. So U here is 0 meter per second into T is 120 second. This portion we need not bother much because everything will turn 0, because anything multiplied to 0 becomes 0, including the units. This is the part where we're going to get an answer from. So even though it's going to turn 0, we need to write it correctly. Okay, so here half into, if you like that, A is 0.1, so we write here 0.1 meter per second square, brought down, so plus minus 2 power has become plus 2 power, into T is 120 into 120, so second into second T square, so second into second square. So these two will cancel off, these two will cancel, 6 are 12, 0. This has become 0, so this part can be neglected. So our answer will be here. This single 0 we can use again to move the decimal right side, so it become 1. So no more 0 here. This 6 into 120 therefore. So 6 zeros are 0, 6 twos are 12, 6 ones are 6 plus 1, 7. 720 meter. So that is the distance traveled. So here, therefore, distance traveled by this bus is 720 meter in 120 seconds. Right, so here 1 is done. So we'll go to the next question. Question number 2, textbook, page 117. So let me read the question. A train is traveling at a speed of 90 km per hour. Let us deal that first, since train is traveling at 90 km per hour. So the first time this train appears in the question is this. That means that is the initial velocity. So that will be, because this is the first time appearing in the picture, 90 km per hour. But in our previous class, the class just before this, we have learned that the SI unit for velocity is U and V is meter per second. But this is in kilometer per hour. So we need to change kilometer to meter and hour to second. How do we do that? For time we already have, so that is fine. But for this distance, kilometer, to change to meter distance, we learned even in our previous sections that we need to know this: kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. Now this is the conversion factor for distance or length. Okay, conversion factor here is 10, meaning 1 kilometer 10 hectometer, 1 hectometer 10 decameter. It goes like that when you go from bigger unit to the smaller units on the right side. The units on the left are bigger ones. Now if you go from small, reverse process, 1 millimeter will be 1 by 10 centimeter, 1 centimeter will be 1 by 10 decimeter. So it goes like that. So we are going to change this kilometer to meter. Now in order to do that, we are moving, excluding the first count, we have to count from second. 1, 2, 3, meaning each movement is 10. So 2, 3 means 10, 10, 10. So that means this 90 has to be multiplied by 3 zeros. Then this kilometer will disappear and meter will come in. So now this is okay. But we still have to change the hour to second. For that we go here, 1, 2 places. We know that 90 means down here 1 will be there, which means 1 hour. So to change to second, 1, 2 movement. 1 hour 60 minutes, 1 minute 60 seconds, so 60, 60. Then this hour will disappear and it become second to the power minus 1. Hour to the power minus 1 will disappear. So now it is matching. This one has become exactly the SI unit for velocity. That's how we change to SI unit, okay? So absolutely necessary to memorize these two, because you'll keep on needing it every now and then, okay? Even in your mathematics, right? So here 0, 1, 2 cancel. 6 is going, so 6 ones are 6. 3 in hand, 6 5s are 30, 0. 6 1s are 6. 6 2s are 12. 3 in hand, 6 5. So finally it came out 25 meter per second in initial velocity. So this is your initial velocity. Okay. Now next part of the question, let us read. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. So you write that brakes are applied to produce a uniform acceleration of minus 0.5 meter per second square. Okay. Now here, since the question has already mentioned brakes are applied, means the train will slow down. So for any object slowing down, the acceleration will be negative. So even if they didn't say minus, we should put ourselves minus when we see the word brakes, or we see the words like the train slowing down, then the acceleration should be given minus by ourselves. Okay, so here, in other words, that is acceleration is minus 0.5 meter per second square, because the train has applied the brake and so slowing down. That's why it's negative. For any object slowing down, the acceleration is always negative. Acceleration positive means the picture of a racing car slowly starting and then increasing its speed gradually all the time. Okay, so acceleration is this much given. Now if you go back to question is saying find how far the train will go before it is brought to rest. So one way to solve this is simply like this. So question is saying, just write the question, how far, one is it, I find it, this is easy for us. So how far the train will go, how far the train will go, okay, before it is brought to rest. Before it is brought, okay, it is brought to rest. So again, this word is going to be one key here again. Okay, so how far means that is the distance that it will go. They are asking the distance before it is brought to rest means the final velocity. The final picture is the train will come to stoppage. So 0 meter per second is the final velocity. Because of the word rest, we know that the train will finally stop because of the application of these brakes. But before it stopped, how far did it travel? The question is asking. If you look at this, you see here, U is there, V is there, A is there. So to find this S, you have two options. Formula 2 and 3 both have S. But we can't use this because there is no information about T. Time is not given in this question. So let us go and check the next one. A is there, minus 0.5 meter per second square. V is there, 0 just now. U is 25 here, see? So that is the one we have to use, third one. So since here we know twice AS is equal to V square minus U square, we use that. Since we are finding S in this case, so that implies S will be equal to V square minus U square divided by this portion into will come down to the denominator. So keeping everything else S only alone and everything else to the right side, we get this. So V is 0 meter per second, whole thing square, because this is V square, minus U is 25 meter per second. Again, careful to put there the whole thing square, you see here, divided by 2 into A. So you can write here 2 into, or like this also if you want. A is here, you see, minus 0.5 meter per second square. Careful that we don't miss out the minus, because this is negative acceleration. So this here, the 0 will just disappear. So this will be just neglected, and minus, don't forget that. Now 25 square is 25 into 25. If you multiply, you will get 625 meter. Bracket means this power will belong to everything inside. So meter to the power 2 meter square, the minus and the plus minus, then 1 2s are 2, so second to the power minus 2. That's how we deal with power outside and inside, multiply them. Okay, down here is here. Now 0.5, this is very easy. 0.5 multiplied to anything, it becomes half. 2 means half of 2 is 1. 0.5 likewise into 4 will be half of 4, 2. So 0.5 into 2 means 1. Plus and the minus, minus. And here meter, so write it that. Second to the power minus 2. So this 2 will cancel immediately, as you can see. This meter and this 2 minus 1 will go. And this minus and minus will cancel. So we are left with 625 plus 625 meter. So you can just write the final answer. Go back to question, and question is saying how far the train will go before it is brought to rest. So distance traveled, you can just write like that. Distance traveled or covered is 625 meters. So that is our answer for this question. Okay, now let us go to the next question. Next one is question 3. Okay, question number 3, textbook, page 117. Okay, let me read the question for us. A trolley while going down an inclined plane, that means there's a picture of like a sloping mountain. So the trolley is rolling down, the trolley, right, which has a wheel, has an acceleration of 2 centimeters per second square. So let us deal with that part first. Here clearly the acceleration of the trolley is 2 centimeters per second square, the acceleration. But you see, the unit for acceleration we know in our previous class, just the class before this, is meter per second square. So this part is okay, but this is not matching. You need to change centimeter to meter, centimeter to meter. So 1 2 to the left. So this time here, before we do that, let me write once here like this, divided by this second to the power minus 2, come down and plus, right? Then here you see long line first, and 2, then 2 is here. Okay, then if since you're moving left, small to big now, 1 2, you need to divide by 2 0, then centimeter will disappear and meter will come in its place. Then second square, no need to touch, it's already in SI unit. SI unit of time is second, so don't touch that. Now here 2 and 100 can cancel, we know that. Just keep it for some time, because 100 in the denominator is good sometimes, easy to divide. This part just write as it is and change this long line means divided by, change to multiplication, then we know there is 1 here down. Just like 5 we'll use as 5 by 1, right? So into means down and up, denominator 1 go up, numerator second square will come down. So this is 2 by 100 meter, and if you bring this up, second to the power minus 2. Now it's fine, it's matching the SI unit of acceleration. So this is the SI unit. Once we're done with that, let's go to the next part of the question. It says, what will be its velocity 3 seconds after the start? So question is saying, what will be its velocity 3 seconds, okay, after the start. So after the start, question mark. So this is one more keyword here, because start, right? Start means it was at rest in the beginning. So that means effectively v is equal to question mark. They're asking for final velocity. That's why we put v. This you can just write it as velocity 3 seconds after the start. Like if you like to put as textbook language. But effectively this is the final velocity they're asking. Then start means initially it was not moving, so 0 meter per second is the initial velocity of the trolley. Okay, having done that, A is there, V and U. How far will it travel? So what will be its velocities of V, U and T in 3 seconds? So time, 3 seconds that is time. So we have here now A, V and U, A, U and T. See here, A is there, U is there, T is there. So easily we have arranged for what we need. So the famous equation, the first one itself is going to solve our problem. So V is equal to U plus, if we use it, right? So that is equal to U is 0 meter per second plus A is 2 by 100 meter per second square, as you can see here. Then T here, it's 3 seconds, so we can just put that into 3 seconds. This part will disappear. Then here 2 3s are 6, and second here 1 gone. 2 minus 1 power, only 1 more left. We're cancelling the power, okay, there. So here 6 2 3s are 6 by 100, and here meter. If you bring this second to the power plus 1 to the numerator, it becomes second to the power minus 1. So easy, very easy to divide this 100. That's why we didn't cancel in the beginning. It's because it was in the denominator, and we can use it to easily divide. Since decimal is not there, means it's here. Divide by zeros means move to the left. So let us move it. So 1 jumped, okay, and 2, because there are 2 zeros, so decimal will come here. 0.06 meter per second. Therefore, our answer is velocity 3 seconds after the start of moving of the trolley is 0.06 meter per second. Okay, so that is our answer. Third question. One more question left before we end this test portion. Question number 4, textbook, same page 117. Okay, these questions are quite easy if you are willing to write it as we take the class and then do proper practice. Okay, it may not be too much practice also. Properly practice it for enough number of times, then they're quite easy to handle. Okay, easy to understand, easy to handle, but it needs some practice. Okay, that means even if you look at it and you feel as if you are understanding it, unless you put your pen to the paper and practice, it won't be so comfortable to you. That's what I mean. You need to do it yourself, right? Put the pen to your paper and do likewise, then it becomes so easy. Okay, so let us do the last one, question number 4. Let me read the question for us. A racing car has a uniform acceleration of 4 meters per second square. So let us write that first. Here very clearly, as we read, A was 4 meters per second square, the acceleration. This is fine, already in SI unit of acceleration, meter per second square. So let us read on. What distance will it cover in 10 seconds after start? So question is asking, what distance right? Will it cover? What distance will it cover? Okay, in 10 seconds after start. In 10 seconds, another keyword. After start, question mark, another keyword. So there are 3 keywords. So that would mean distance means S. So the distance that we are searching for. 10 seconds means time. That is fine because SI unit of time is seconds, right? And after start means that is the initial velocity. Initially it was not moving. That means start means we won't say if an object is already moving to start. Start is a picture of, the question is suggesting to us that this object was initially, the racing car was stationary and it moves. So stationary in the beginning means initial velocity is 0 meter per second. Okay, so we have here to find S. I think second one will do. See here, S is equal to ut plus half A is also there, t square. So directly we can do that. This is quite easy. Since we know S is equal to ut plus, so if you like, you write your initial velocity, okay, half a t square. So let us write it 0 meter per second for u here, into t is here 10 seconds, plus half into A is 4 meter per second square, into t square. So t is 10, so 10 into 10, okay, 10 into 10, so that will give you yes, 10 into 10. So this will be 10 into 10, second into second, second square. These two can cancel therefore, and this cancel, 2 2s are 4. This portion will disappear because 0 multiplied to anything, everything will become 0, including the units will disappear, right? So here 2 into 10 is simple case of 200. Only meter is the unit left. So we can write here, therefore, what distance will it cover? So we'll just write the final answer. Distance covered is 200 meter. Okay, now this is the last question completed. You can now go and appear this test 8D. It's quite simple, okay? If you see, then the questions are identical, only there will be a slight change in the number, okay?